one of the founders of an app startup. While I wait for the builds of the app to come out, how do I see the work that the team is doing? Welcome to Totally a Thing. I am Sarah Smith. In my previous talks on how to build an app, I've discussed source control briefly. Github, owned by Microsoft, is probably the popular cloud surface for source control. Okay, but how does that help me if I'm that app startup founder? If your app-based startup is going great, then your team will probably be implementing product features and code for that, and it'll be going into your source control system many times a day. But what about if something is going wrong? How can you check up on that? Do you wait for your engineering team to tell you? I've talked a lot in my previous episodes of this publication that startups can have a lot of problems, especially in that early app building phase, and especially when there's poor engagement between the founders and the team. That can happen even with the best will in the world if you're super busy rushing around trying to hustle. I talked previously in this session on my developer left me about Carol, not her real name, who had her entire team sort of disappear. And what I suggested back then was get the code, understand the code. So it's very important as a backstop. I'm not saying that's going to happen. You might not think that will happen in your business. I also talked previously about the role of your code repository in automation of your project, about how critical it is to delivering new releases to your customers, and how your developers are constantly uploading changes to your source control system as part of their 2-weekly cycle. And finally, I talked about the iteration that is constantly happening in your team as your cycle, usually a 2-weekly cycle called a sprint, that is happening, and we're getting features planned, then they get delivered, we review what was done, and we debug any problems. So I've done to death the why of being a founder who understands how to find your code and know where it is, know what's going on. In this section, I'm going to assume you already have that motivation. You've looked at those previous talks and you want to know, well, what's the what? What's the how? How do I do this? I don't now understand source control. Or maybe you are a technical founder and you just want to see what this could possibly mean for a startup. After all, if my business was a sandwich bar or a t-shirt printer, I could go down to the kitchen or down to the factory floor. But if source control is a mystery in your app-based startup, you need to take some time out to decode that, because it's the one thing that is going to be keeping your business running. So the what? In the next 10 minutes, I'm going to show you what source control might look like and give you some idea of how it works. And then I will wrap up with a short list of next steps to give you as an appreneur to get ongoing insight into your project so that you can work with your team collaboratively. As a bonus, if you're an engineer, you'll see the way that I tend to work with Git on the command line. You might discover something new. For non-tech appreneurs, trying to get a handle on source control can be tricky. So here's a not great analogy, but think about the difference between a document on your local computer and, let's say a document like a PDF that you downloaded or something. Think about the difference between that and an email. That PDF you downloaded, it's in your downloads folder. You know where it is. It's located in some place there. Now compare that with the emails that you read on your phone. They kind of not exactly on your phone or your computer, though you read them there. They're more in the cloud, and a code repository is a bit more like that. It's in the cloud, but synced locally. kind of. Another big difference, which I'll be focusing on in this session, is a code repository for your project is built in small steps. So source control is designed with that in mind. So I'm going to have a look at a couple of projects from the engineer perspective, and you'll see how I explore that code, how I download it, make changes to it. And let's just start with a GitHub repository for this product that I built quite some time ago now. It was called plistinator. It runs on 3 different platforms, but this is the product page for the Windows version of it. And over here you can see the source control for plistinator up on Atlassian's GitHub. So Atlassian makes a product that's similar to GitHub. It's called Bitbucket. It's got the same kind of thing, so I would sign into it here. It's a secure system. It's not an open source project, this particular one. It's proprietary. I wrote it over the years in C++ in collaboration with some other folks who I hired to work with me. And generally the access to this source code would be limited to people who have permission to access it. So let's have a look at what it looks like. So there's a bunch of files from the project. You can see the sort of structure. We've got a source directory at the top there, and we've got a whole bunch of project files inside here with different source control in them. And even if you're not a technical person, you might see this file here, binary plist file, for example. So we know that this is a plist editor program. Plistinator, that's what it does. It's there for editing plists. So we'd expect to see file names that have to do with that. There's something to do with the license. So this is a licensed product. So updating whether or not the folks have got a license. There's a dialogue about the license, all in those source code files. Also, we've got this README file, which is what we see here. So one of the things that source control systems online typically do is they will expand out that root level README file and give you some nice documentation to help you get started. Now, I'm putting this up because this is an old repository and it's not a particularly good one. It was written pretty fast, and if we look how many files there are inside here, there's 94 source code files. That was pulled together in a pretty brief period of time. So let's have a look at the Git log. You can see there my collaborator Sergey wrote quite a bit of code, but in the early days it was all written by me. The binary serialization was done by me. So a lot of different changes over the years. Now you can see these small incremental fix-ups that have been done, implementing one piece, then the next piece, then the next piece. So what is happening here with these commands that I'm typing? If you're not a technical person, that's fine. The most important thing to understand about that is I showed you the cloud view here inside of Bitbucket, and I'm showing you the local code that I've got here as well. So all these files stored locally. So that's a key concept to understand with source control. We've got our local copy that our engineers are working on, then we've got our cloud copies of that, which tends to be our master copy. So let's have a look at another project, and this particular one I don't actually currently have it in here. So we can see we've got chestnuts.js, various different things, but the C++ version of it is not currently here. And if I look here I've got this repository on GitHub called Chestnuts. It's actually a public repository. You can go and play with this one if you like. It can be accessed publicly, and I've MIT licensed it, so I wrote all the code in here, but I've made it publicly available. Somebody's started 4 times, interesting. So I will grab this clone URL, and then from here I can do git clone like that. Now that is the equivalent of downloading. So to go back to the email analogy, what I've effectively done is opened my email client and pulled down that email, those documents locally. And if I look again now, we've now got Chestnuts. This directory wasn't there before, there was just that one. So if I go into Chestnuts and have a look in here, we've got different subdirectories inside of it. If I look at this coins one, I've got more files inside of here. So if I look at the documentation for this under the README file, and remember that README is in the root directory of the main project, I've got information here about how to actually use this code and how to run it. Now I would expect to see this on any good source control repo. It should always contain documentation of some sort. There can be good and bad documentation, but there should be some documentation like this that's going to tell you how to actually use the project. So here I don't currently have a binary file, but if I type this command, it's going to compile a code. Now I've got this binary coins. And I can run it like that, and it's going to produce the result saying that there are 5 different ways to make change of 10 out of these coin denominations. So that's the given an amount N and the denomination C. It's just a particular one of these little test programs that folks will get you to write if you are going for a job interview. And there's a bit more explained here about it, how it was done. So again here we can, by the way, this git short is just an alias for git log. Git log by itself is kind of hard to see. So I have created this alias git short, which just has this pretty format. So you can kind of see my process for developing it here. I added all the different pieces of this project over the years. Now, if I make some changes, let's say I edit this CPP file and maybe this README. I could put up the top here some sort of comment. This is the main entry point. Go over here and say, this is an example, the first line of the test data contains count of the denominations. So in the case here we've got n equals 3 and we've got 4 entries in the denominations table. So I'm just adding a piece of documentation there. And now Git can tell us what has changed. So we've got git diff, so we can see there's the comment and then this extra piece of text in the README file. Now what I want to do is I've pulled that down. Now I want to add those changes into source control. So what I tend to do is use this local command, git add -i or add interactive, and then I can choose 2 for update. I can select 1 and 2 to update those 2. Now that they are updated, I'm going to say git commit -s -m improve documentation. Okay, so I've now made that change, and if I do git short again, you can see that my change is there. If I look at that change, you can see that it contains all of the alterations that I did. It contains the commit message that I used, and because I put that -s in there, and because I have everything set up right, it's actually signed it using my local RSA key to prove that this was done by me. And then I can now push that up to the repo. Okay, so that is a lot of technical commentary that's not necessary to understand exactly why I did what I did there. The main takeaways from that are that I pulled it down from GitHub, from the cloud, and because I have the authentication all done locally, push my changes up to the cloud, and we should be able to see them. So let's take a look at the website. And I'll just do a refresh. Last said 4 years ago. Now we're saying 1 minute ago. So the thing about source control is that Git never forgets. I did a previous talk about how to make Git forget, and it is a massive pain to do it. You've got a, you've got this thing where all of the things that you've put into source control are there, even if you didn't potentially intend to have them there. So secrets, for example, bad things that you said about your boss, all of that stuff is still in there. We have this set of commits that Git never forgets. It's stored them in there. And I also showed you signing commits. What if you had a disgruntled employee? Let's call him Joe. Joe left and decided that they were going to put a backdoor in your code. Gone from the company, you haven't revoked their access yet. You're planning to, but in that last wrap-up phase before Joe sort of left, Joe had access to the code. They potentially even had access to somebody else's account afterwards. That's another thing that might have happened. And what's Joe done? They've gone and put this backdoor into your code and compromised your product. But with signed commits, you can see this verified stamp here. And what this is going to do is basically say that this GPG key, which is stored locally on my laptop, was used with that -s switch to sign that particular commit. These unverified commits, even though it's got my email and stuff on there, it really could have been done by anybody who happened to have my username and password for GitHub, or even just knew enough to replicate that stuff. But they have to have that particular key, which I keep securely stored right here on my local laptop, and it gives some measure of protection. It's a good thing to do, and it doesn't take that long to set up. There's an article here on the GitHub docs about signing commits. You can Google for that and look up how to set up verified commits like that. Good thing to have Don't need to put in a lock to force people to do it, but it's a good thing to just have on there. So now that you've got all those commits on there, so as a tech-savvy founder, you want to make sure that you have your own GitHub account. It's not going to be an account that is owned by some other team member and you just happen to know the password and you log in with Alice or Carol's user ID and their password. You need to have your own GitHub account, and the reason for that is that you're going to promise to use this access very wisely, very carefully, because you're going to have admin rights to the repository. What that means is that if you're in the situation that Carol was in, where the whole team has left, you've still got the code, and you've also got the ability as an admin to invite new collaborators into the repository to get them working on the code. Even if you're not technical, you can talk through those folks how to get that access. Code repositories are quite well protected. It's quite hard to make a mess of them as long as you don't press any button that says edit, as long as you're just browsing. But you do want to have your own GitHub account with that access. Then, step 2, regularly after every release or after every sprint, you're going to go through that list of commits, that's this list here, and just click into them, and you'll be able to see which files got changed. So typically there would be some sort of message here, and there should be some detail in that message. That's one thing to check for. So you're going to be looking for detail in those commit messages. And you're also going to be looking at what files got changed. Now, I'm a software engineer, and it's very tempting when you're an engineer to get distracted by other things. If you are in a startup, you want to avoid that. If there is a need to go off and do some sort of maintenance work, generally you want to make a separate task for that and check in with the other folks on the team. Just make sure that that's the right priority. So if you're a founder and you're just curious, you can have a look around here and you can see, well, was Sarah working on the feature that related to coins? Well, if not, why was this file changed? What was the necessity there? If you're seeing big changes to files that don't seem to relate to whatever this message is, that's potentially something that you could discuss with the team members, maybe with the engineering manager, and just say, oh, hey, look, I'd like to better understand why this is happening. Are we losing focus? Is there an opportunity here to be a bit more efficient? Something you can also do is potentially even look into things like function names. It's kind of an extra credits type thing, because oftentimes you're going to get into quite a lot of technicalities, but usually these function names are not meant to be particularly obscure, and they shouldn't be. So this one here is display a vector. You think that might be pretty obvious. The actual Fibonacci function, so this is a thing that's about the Fibonacci feature, so that function name kind of makes sense. Again, it doesn't hurt, even if you're not technical, to just have a browse through these files and just kind of see what the names of functions are, what pieces of documentation, what files we've got in here, and what people are writing in code. One story, bit of a nightmare. I'm not going to suggest this happens a lot, but my client had worked with a consulting firm here in Brisbane. There was a lot of young guns at this firm, and things had broken down. The work was not getting done. She was very unhappy. They had released only about 80% of the product, and she was just way over budget from what they promised. And then when we looked at the code, there was a lot of third-party code that had been dragged in and dropped into the project, And there was also this big screed waffling on about how terrible the client was, and like calling her out by name and saying a bunch of rude, terrible, unprofessional things. Now, you would never expect to see that. Now, I found this when I was doing a review of the code, and I didn't need to be highly technical to find that. I expect engineers to behave professionally. Like, a bit of larking up is fine, but I think if people are spending time doing things in the code base that don't further the aims of the project and then charging you for their time, that's not potentially somebody that you want on the project. All right, to wrap up then, that is your assignment as a founder. You're going to be jumping into source control via the GitHub API, or in the case of Bitbucket, if you're using that, or GitLab, whatever it happens to be. You're going to be clicking on this section here that says commits, and you're going to be looking through to see what people are saying about the changes that they've made. You're going to be seeing, well, why was this change done? How much work was involved in that particular change? What did it actually sort of do? And, does it kind of fit with the intent of the project? What about readmes and documentation? Are people writing documentation so that other folks can get involved in the project and get up to speed quickly? And finally, are there any team dynamics issues that could potentially be displayed from your investigation of source control? If you see two people making changes over and over and over again to the same files, and it looks like it's just going back and forth, flipping and flopping, what is going on there? Is that some sort of power struggle that they're having and playing out in source control? So having a passing familiarity with your project, looking at all that money that's being spent, it's really worthwhile for you as a founder, and it's going to make you more effective at getting this capability layer here that I've talked about in previous talks, getting that team velocity happening, and basically working collaboratively with your team. Okay, thanks for listening.